what we're going to discuss in this chapter is how to prove that we have triangles congruent. So many chapters ago we studied congruent triangles, and that means that they're the same size, same shape. And two triangles are congruent if all six pairs of things, like this three sets of angles, like angle A congruent to angle D, angle B congruent to angle E, and etc., and the set of sides, like segment AC congruent to segment FD, and etc. If you had six different pairs of corresponding parts that were also congruent, we knew that triangle ABC then would be congruent to triangle DEF. Well, what we're going to do is we're going to prove that we have congruent triangles this chapter, and to do this we don't need to actually have all six pairs of corresponding parts congruent. There's 5 total ways we're going to be able to prove triangles congruent. Today we're going to learn 4 of them, and let's just kind of go through those on this front side of this worksheet. So here's 4 of the 5 ways we'll learn how to prove that we have enough information that triangles congruent. So the first way is called side-side-side congruence theorem, and we'll abbreviate it like this: side-side-side SSS. We'll never say SSS. We'll call it side-side-side congruence theorem, but we'll just write it down like this. And here's what it means: if you've got 3 different sets of sides that correspond to each other, and they're congruent, like see segment AC is congruent to segment D, that's an F right there, DF, like they're congruent by the tick marks. Then you got these blue set of sides, and you've got these green set of sides. You have to have 3 different sets of sides that correspond to each other, and they're also congruent. That's enough information to prove that those 2 triangles are congruent, and how we write it down is side-side-side congruence theorem. That says that those 2 triangles would have to be the same size, same shape. So that's one way we'll know. Another way is called side-angle-side congruence theorem. Now notice when it's written like this, it's a side, then an angle, and then a side congruence theorem. This angle is between the 2 sides. Like if I go around, let's go from starting from this tick mark, if I go around counterclockwise, I've got a side, then I've got this arc mark right here, and then I got another side, a single tick mark, single arc mark, double tick mark. In the other triangle, don't I have that exact same information? Single tick mark, then that single arc mark, and then this. So like if this was 4 inches, and this was, let's say, 40 degrees, and this was 6 inches, then this would be 4 inches due to the tick marks, this would be 40 degrees, and this would be 6 inches. That's enough information right there to prove that those triangles would have to be congruent because of what's called side-angle-side. That angle is between the 2 sides. Notice if you do this, if you had 2 triangles right here, you went side, this angle, this arc mark, is not between those 2 sides. If you got to go around like consecutively, either clockwise or counterclockwise, if you went from here to here to here, that arc mark is not between the 2 sides, so that is not enough information. Here's also another one that says this is not side angle side, and people go, well, okay, what if you went from here, let me use a different color. What if you wanted to go from this double arc mark around this way, Mr. Fonesteel, and said I want side, angle, side? This doesn't work because of this fact. Look at how many things you skipped over. You can't skip 2 things in a row. Like if I went around the clock this way, isn't it true that I skipped over this angle right here? I skipped over that angle, and I skipped over this side. I just skipped 2 things in a row. I skipped an angle, and I skipped a side. You can't skip 2 things in a row. So you jumped too many steps, basically. You can't go side, skip, angle, side. It just doesn't work that way. So that's not side, angle, side. Why those 2 triangles are congruent if they are. So side, angle, side, you have to go around consecutively, and the angle, the arc mark, has to be between the 2 sides when you do it. So it's got to look just like that. Another way to prove triangles congruent is called angle side angle. And notice it's like the same idea, only backwards. That side has to be between 2 angles, just like this. If I went here and I went around consecutively, I went from an angle to a side to another angle, and it's right in a row: angle, side, angle, angle, side, angle. So that is another way that just to prove that you have enough information to say those triangles would have to be congruent to each other if angle, side, angle. Here's an example of angle, side, angle not working because you see that the tick mark is not between the two arc marks, and what it really boils down to is if you wanted to go around like this, it's like, well, I'm going to put the tick mark between the two. You skipped too many things in a row. You skipped over highlighter. You skipped over this segment, it had no markings on it, and you skipped over this angle, which had no markings in it. You can't skip over two things in a row that don't have marks on them. I guess that's a better way to say it. You can't skip over a segment and an angle in a row that don't have markings on them. You skip two things without markings. So that doesn't work for angle, side, angle because the side is not between the two angles because you skipped two things in a row. Okay? And then on number 4, the final way today that we'll learn how to prove triangles congruent is called angle, angle, side congruence theorem. Angle, angle, side. You notice the order you go, and you got to go from an angle to another side congruence theorem. So it's just like this. If I went around this way, this works. And people go, wait a minute, you skipped over something. It's okay to skip one thing in a row. Like, see, I had this arc mark, and then notice I totally skipped this side. It didn't have a marking on it. This segment does not have a marking on it. So I skipped one thing, and then I got to this angle, and it does have markings in it. So it's not like I skipped two things in a row. I only skipped one thing in a row. I went an angle, skip, to an angle, to a side. Angle, angle, side. Angle, angle, side. So that's another way to prove triangles congruent. But angle, angle, side is the trickiest one of them all for this reason. Let me back up here. If you're going to go single arc mark, double arc mark, then side, this guy has to go in the same order when you go around the clock. So I went around the clock clockwise. You have to go, if this one went single arc mark, double arc mark, side, this one has to go single arc mark, double arc mark, side. The arc marks, the two angles, they have to be in the same order. Single, double, side, single, double, side. Here's an example that doesn't work. Like, if you go around the clock this way, from here to here, notice you went double arc mark, single arc mark, side, and then same direction that you go around here, same orientation. You went, the arc marks got all switched around. It went single, double, side. So this is not angle, angle, side because the angles were in the wrong order, right? If I put numbers in there, if this was 70 degrees and this was 60 degrees, then this one, the double arc mark, is 70 degrees, this one's 60 degrees. You switched them around, right? It has to go 70, 60 side, 70, 60 side, and it didn't work that way. So not angle, angle, side situation. And the fifth and final way to prove triangles congruent is if we have a right triangle. That's what makes this be very special. We have to have a right triangle. If we got a set of hypotenuses congruent to each other, like these guys, and a set of legs congruent to each other, boom, boom, and again, it's got to be a right triangle, then we can prove these two triangles congruent by what's called hypotenuse-leg congruence theorem. And this one's one of the most obvious ones because, dude, you got to have a right triangle. So hypotenuse and a set of legs congruent to each other, then those are congruent. So let's try some over here. First, they want us to list the 5 ways to prove triangles congruent, so we just got to practice getting good at that. The first one was side, side, side congruence theorem. And got to have the congruence theorem. Then side, angle, side congruence theorem. And then just kind of switch those letters around. Angle, side, angle congruence theorem. And then angle, angle, side. That was the trickiest one where the two angles had to be in the right order. And then the last one is hypotenuse-leg congruence theorem. So these are the 5 ways to prove triangles congruent. Let's check out these problems here. It says A, determine if the triangles can even be congruent, so yes or no. If we say yes, then state which one of these 5 congruence theorems we did, and then C, write a congruence statement. So let's dive in. First, let's see if any of these ways work. First thing I always check is side, 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 and in this triangle I don't even have like 3 sides with tick marks on them. It's only got 2 sets of sides with tick marks, so that's no good. How about side to angle side? Remember, you got to go around the clock where you can't skip 2 things in a row, so I go from a side to this angle to a side without skipping anything. Can I do that on this one? Side to an angle to a side without skipping anything. And it doesn't matter that one time you went around clockwise and the other time you went around counterclockwise. This is a big fat yes. And these triangles are congruent by side angle side congruence theorem. And then we've got to write a congruent statement. So we name the first triangle whatever we want. So we'll call him triangle ABF. Whatever, it doesn't matter. And then you got to put the second dude in corresponding order. So A is where one tick mark and no tick marks come together. That corresponds with C in the other triangle. B is the dude with the arc mark, so he corresponds with E, which is the dude with the arc mark. And then the only other letter left is D. So cool, let's keep trying. Here's our 5 ways to prove triangles congruent up yonder here. Let's see if we can do side, side, side. That's a no, because this segment over here doesn't have any tick marks on it. So side, angle, side. Remember, we go from this side, let me get my highlighter back again. We go from this side around to this angle, and then you notice how I skip over the top of this dude, and I skip this angle. I totally just skipped 2 things in a row. To go side, angle, skip, skip, side, that's too much. It doesn't work that way. So side, angle, side doesn't work. Angle, side, angle has 2 different angles with it. So it's like, in the triangle I only have 1 arc mark in that scenario, so that's not going to work. And neither will angle, angle, side, because again it has 2 angles with it. And then hypotenuse, leg, I don't have a right triangle for that. So all 5 of these bad boys failed, so that's why this is a no in this situation. Then we don't have to do part B and C, because that was only if it was a yes. So over here, let's try. Definitely can't do side, 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 or side, angle, side, because I don't have enough sides. But I got tons of angles. So I got an angle with an arc mark. Then I go to this side. Then I go here. So there's like an angle, side, angle situation. That's cool. Let's see if I can do that in this one. I go angle, side, angle. So nice. That does work. So that's a yes by angle, side, angle, congruence theorem. And then to name those dudes, let me just erase all this stuff. Name the first triangle whatever you want. So I'm going to name this triangle right here triangle NOY. And he's going to be congruent to triangle N corresponds with X because he's the guy with no arc marks in him. O in this green triangle has the single arc mark. He corresponds with Y in the other triangle, who's got the single arc mark. And Y in the green triangle has the double arc mark. He corresponds with O in the other triangle, which has the double arc mark. So that's kind of tricky. Also, you got to go from a green triangle to a red triangle. The green single arc mark has to go with the red single arc mark, and the green double arc mark has to go with that. So be careful with that. All right, let's see if we can try this one. Side, side, side is a no because I don't have enough side lengths. I don't have all 3. Side, angle, side. Ooh, that looks nice, and I didn't skip 2 things in a row. Can the other triangles do side, angle, side, side, angle, side? Hey, that's a yes. These triangles are congruent. Might want a pen to write these things down. By side, angle, side, congruence theorem. And then name this triangle whatever you want. Triangle ACD is congruent to triangle A is where 2 tick marks and no tick marks come together, so that's S. C was where 1 and none came together, so that's I. And D went with O. So neat. Let's give this guy a try. Got a couple of angles, so I can skip over the side, 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 and the side, angle, side, because I don't have enough side lengths for that. But how about angle, side, angle? You know, I could go angle all the way around this way. Oops, I skipped 2 things. I skipped this side and this angle, which has nothing in it, so that's not going to work. So how about we go this way, angle, angle, side. That's the tricky one because this one went double arc mark, single arc mark, side. When I go around in this guy and I go in that order from the angle to the other angle to the side, I have to go in the same arc mark order also. This one went double, single, side. This guy goes single, double, side. That's not the same. So it's not this, or this, or this. It's not this, and it's not hypotenuse leg because I don't have a right triangle. So this one was a no. trust me, it gets easier. It just takes a little bit of practice. So this guy, oh, I like him. It looks like a side, side, side. You got a single in each triangle, a double in each triangle, and a triple in each triangle, so that's a big fat yes. That's usually the easiest one to see by side, side, side congruence theorem. And then we'll call the first one triangle ABC. If they ever use A, B, and C for letters, please call the triangle ABC. It's just very, very nice that way. A is where 1 tick mark and 3 tick marks come together, so that's going to go with D. Don't forget the triangle symbol. B is where 1 and 2 come together. 1 and 2 come together with E. And then the last letter is F. So nice. And then finally, well, I guess not finally, we got more problems, but let's see here. We do a side, side, side. We don't have enough for that. Side, angle, side. If I go from this side to this angle, then I skip. Can't skip this dude and this dude. That's 2 things in a row that I skipped, so I can't do side, angle, side. Can't do angle, side, angle, because I don't have enough angles. Same thing with angle, angle, side. But how about hypotenuse leg? Do we have a right triangle? Yes. We got tick marks on the hypotenuse? Yes. We got tick marks on a side? Yes. So this is congruent by hypotenuse leg congruence theorem. And then we'll call this dude triangle ABC. And that's congruent to A is the right angle, so he goes with an E. And B is where 1 tick mark and no tick marks come together, so that goes with F. B is the only other letter. So cool. Why don't you give the video a pause and see if you can get number 8 right here quick. So pause that video and see what you think. Alright, you can't do side, side, side on this guy. Can't do side, angle, side because you don't have enough sides with tick marks on it. So angle, side, angle, and nope, it looks like an angle, angle, side type of situation. You went from an angle to a side. That's the tricky one. Double arc mark, single arc mark, side. If you go around from the double arc mark to the single arc mark, can you get back to the side? So that's a yes. By angle, angle, side congruence theorem. And we name it triangle SET, whatever you want to call it, since it didn't use A, B's, and C's. Is congruent to triangle S goes with B, E goes with E again, and T goes with T. Yeah, and this guy looks like an angle, angle, side situation because we went from an angle to a side, but it goes double, single, side. Does that happen again to go from an angle to a side? Do we go double, single, side? Oh yeah. So angle, angle, side. And that's triangle. We got an ABC, so we'll call him that. Congruent to triangle. A is the double, he goes with D. B is the single, he goes with E, and F is the only other letter. And then the last one, I'll let you pause him and see what you think. If I see a right triangle, the first thing I check is to see if I have a hypotenuse leg. And I don't have hypotenuse leg because, hey bro, the hypotenuse doesn't have any tick marks on it. But it doesn't mean these triangles aren't congruent because I got an angle and then a side and then another angle in this one. So angle, side, angle, angle, side, angle. And people are like, hey, but those are boxes, not arc marks. And I'm like, well, okay, but they're like the fanciest kind of arc marks around. They're a nice square box. That's 90 degrees, and that's 90 degrees, so they're definitely congruent. So this was angle, side, angle congruence theorem. And triangle ABC is congruent to triangle. A goes with F, B goes with E, and D is the only other letter. So, cool. Give these puppies a try. Come on in if you have any questions. Have a good one.